All right. Good afternoon. How was lunch? All right. Okay. This is the best conference because it's the only one where you can eat copious amounts of bacon for 5 days in a row. It's the best. It's the best. Good afternoon. My name is Ben Brautigam. I manage a group at Penn State called Advanced Learning Projects. We're in Central IT. And basically, we are a design and development group where we look at emerging technologies and we do a lot of mobile development and things like that. I'm joined by Justin Miller, who's on my team. Today we're going to talk about a few things, the Apple Watch being the main focus. But we're going to start out by talking about a problem we're seeing at Penn State. And if you work at another institution, you might be seeing it too, especially large ones. And then we'll talk about how we can build an app for the watch that might solve that, or any wearable for that matter. And then we'll spend a lot of time in Swift. We have a lot of code to share with you. I'll show you, we'll give a demo of the watch app, and then we'll go into the code and see how it's all put together. It's not as difficult as it may sound. Then I'll turn it over to Justin, and we'll look at some other Swift code and a Mac app, a utility that he made, where we can start with that. We hear this a lot in higher education. Last semester, we had the opportunity to do some focus groups with students, and just to talk about how they use technology throughout their day, what they think of Penn State services and Penn State tools that we offer. And while the ones that they found were really great, we were talking about others, and they said this and well, I wish I knew that existed, or I needed that 3 weeks ago. So with all the tools we build and all the services from vendors that we buy, a lot of times those get missed by our students or our customers. So how can we use the watch or use a wearable, something really convenient, something really close, to kind of give the right tool at the right service at the right time? Because frankly, search isn't really working anymore. If a student needs to build a website, they don't know if Penn State offers a tool to do that. If they do, how do they find it? Do they go on Google? It could be a big struggle for them. Whereas, a faculty member might just want to stand up and say, I need to edit a video. And they should have the service come right to them. So don't search. Students and faculty should be able to summon the tool, summon the service that they need at the right time. So the right tech at the right time. So how can we do that? Well, we constantly have to be listening for what they need at that specific time. And something like the Apple Watch can really help with that because of something called voice recognition. And the goal with any watch app is 3 things. It has to be really, really simple. 1 button, 2 button, 1 display, 1 label. It has to be quick. The whole purpose of this is to just quick glance at something. And it has to be actionable. I have to get some value out of it. So using speech recognition, we put a little app together that allows faculty and students just to generally say what they need, and then the watch will hopefully offer the Penn State service that solves their problem. So with Justin's help, since we can't really mirror an Apple Watch yet, we have a webcam.
Old school.
All right, I'm going to sit down. No, it's not, unfortunately. If I had $1,000, I'd buy one on eBay. All right, I'm just going to put my wrist down like this. All right. So here's my app. And if I'm a student and I need to build a website for a class or my personal portfolio, I need to build a website. Maybe. I need to build a website. Well, this is working great. Let's try something else. I need to edit a video. Okay, so I said I need to edit a video. It just so happens that Penn State has a service called Media Commons, which allows students and faculty to edit videos and produce video content for free. So the app offered that service and also offered the web address to get more information on that. Let's try another one and hope to God it works. I need to build a website. Okay, so Penn State also has a WordPress service called Sites at Penn State. So just by saying the fact that I need to build a website, the algorithm can take that and provide a custom Penn State service that caters to that need. And there's the web address where they can start their own website for free. Now, what if I'm a faculty member and something goes wrong with the projector during class, or I need some help right away? MacAdmins is actually put on by a group called CLC at Penn State, Classroom and Lab Computing. And they have some great services. So I can say something like this. I need help with this podium. So here's classroom support, and the phone number I can tap and call right from my watch. So some pretty cool stuff you can do. So now let me just switch to the code, and we'll go through this a little bit. And everything we're going to show to you today is in Swift. This will not be kind of an introductory course to Swift. This will be, here's what it looks like, here's some things we've done with it. Tomorrow, I believe, there is a Swift kind of pseudo workshop happening where you can do some more in-depth stuff with it. So this is Xcode, and to add so watch apps are simply extensions of iPhone apps for right now. And so to do that, all I have to do is start a new app, or start a new project in Xcode, and go up to File, New, Target, and I can add my WatchKit app and extension right here. I just click Next, and it adds it right to my project. And you can see it right here. Here's the extension with my interface controller, and the app with my storyboard. So we can start with the storyboard layout. As you saw, this was the first screen on the watch that you saw. It's simply just a big button. And when it works correctly, it will then call a bit of code that listens for speech. And depending on what the user says, just as just a very rudimentary example here, depending on what the user says, it can display the appropriate tool, the appropriate service that they're looking for. And these here are 3 separate view controllers that can be called depending on what the user's saying. Of course, you can take this a lot further and build a database out of this that can be continually updated with keyword extraction and build a really robust kind of service catalog that can be accessed with this app. So this is the watch storyboard, but again, watch apps are merely extensions of iPhone apps. So up here is the watch app, or I'm sorry, the phone app. So here's my main.storyboard. And I don't have an iPhone or an iPhone component to this app, but if I wanted to, I could design an interface for this that could work on any iPhone size using one storyboard, which is really nice. So just to kind of demonstrate that, I'm going to throw a button on here and a label. And I have some image assets for my watch app down here in the WatchKit that I can also access for phone stuff. So I can make a label here that says, whatever I want. I'll center that up nicely, place it here. And then this button I can reuse the same image I do in the watch right here. And then with just a little bit of tooling of the same code I use for the watch, I can have the same functionality on the phone. But rather than running this in 5 different simulators to see what it looks like, Xcode has a really nice feature where I can do some previews of the storyboard right in here. So here's how it would look like on an iPhone 4, or a 4-inch iPhone. And then I can add some things here. So this is the iPhone 6. You can see we have some problems in layout, which we can get to. And here's a 6 Plus. You can also add landscape. Now the cool thing about these previews is, as I change things in the storyboard, it's actually updated live. So if I move something over here, it responds nicely in the previews. And I don't have to run this in the simulator every time. So let's make these a little bit formatted better. So I can use auto layout to add some constraints to these things to center them up no matter what device I'm using them in. So this MacAdmins 2015 label here, I can just pin that to the top. I'm sorry. I'll select it and pin it to the top. So now, no matter what device I'm using it on, it will always be pinned to the top of the screen of this this pixel space. So you can see I have that. I have that here, but it's also not centered. So let's fix that. I'm going to go down here to my constraints, and I'm just going to have the system add the missing constraints for me. So now you can see the label is centered nicely and pinned to the top, but I ran into some trouble with this button. So I'm going to do the same thing. I'm also going to make this sized a bit differently. So I can make fixed heights and widths using constraints. And you see how that fixed it in all the previews now. So now using one storyboard, I can make one interface where I don't have to worry about the device size and the screen size. Using constraints, I can make that all automated. But let's look at the code. So down here in the watch, I have an interface controller.swift. And this is pretty simple. The entire code for what you saw in the demo, the part that worked anyway, is from this one IB action. So when I tap that button, I presented a text input controller. Here, you might see these when you're doing a text on your iPhone and you see some suggested responses up on the top above the keyboard. You can also see that microphone icon. You can have it present suggestions, but you notice when I tapped that button, it went right to the listening mode, or it was listening for text to come in. I made this parameter nil, and then a plain text input mode. And then I took what the user said, and they can say as much as they want, and that becomes input. I convert input to a string, and then based on that string, I look in that and see if there's any of these keywords here. So if the string contained the word website, I then presented the view controller appropriate to that service. If the string contained video, same thing, or if it contained the word podium, same thing. Now again, this is pretty rudimentary, but you can really make this more robust depending on what you want to do with it. So just to show you what the simulator looks like for the Apple Watch, I'll run this using an iPhone 6 simulator. Here's the iPhone, and here's the Apple Watch simulator. Now the thing with the simulator is you can't talk to the simulator. The speech to text won't work, but you can offer suggestions. So let me just add an array And then instead of having this be, can everyone see this, by the way? I'm sorry. Okay. Instead of having this be nil, I can point this to the options array I just created. So now let's stop it and run it on the simulator once more. So now if I tap the listen button, now I get some options instead of it going right to the speech to text, which I could if I did right here. I'll just make that nil again. And if I had my actual iPhone connected to this machine, I could run this app on my actual device, and then what it would do is, since this watch is paired with my phone, it would then install the watch component on my watch, and I could demo it here, which is what I did today. And you can also, in Simulator, you can run these different devices as well. Going back to the storyboard, there really isn't much to it, and I think it's intentional by Apple because, again, the focus of the Apple Watch is for simple, glanceable kind of these moments that you create. So the UI kind of toolset here is rather small. I can add an image, I can do a line separating content, a button, switch, slider, labels, these kinds of common things. The map view as well. And then if I wanted to do some more kind of intricate animation, I could use GIFs or something like that, or any of the animation frameworks that you can use. But editing a view controller is pretty simple. This right here is I have the background of these view controllers simply set to an image. So this is what it would look like blank, and then I can add the background, whatever I wish. I can also add a new view controller here, and I can drag in an image and kind of lay that out how I want to, or switch. And as you add content, the screen adjusts, and this would obviously the user would be scrolling at this point to see this additional stuff here. All right. Are there any questions or anything at this point? Yeah.
Just a quick general question. How many iPhones, the Apple Watches do you find on campus already? Or is there a sufficient demand for this? Or
We haven't really done a what's that?
Can you repeat the question?
Oh, sorry. Thanks, Rusty. He asked how many Apple Watches we're seeing on campus right now, and is it even worth doing this at this point in time? Honestly, I haven't seen a lot. We haven't done any formal surveying of students to see what watch they own. We did purchase a set of watches, and we'll do some studies with students in the fall. We'll actually let them use watches and then use apps we develop on it and get their feedback from it, which will be helpful. But we're kind of interested in seeing the entire kind of gamut of what wearables students are choosing to wear. But other than, I'm seeing them in Starbucks, and they came out at the end of the semester, so in fall I think will be a good indicator if we're seeing them more. Right.
Yeah.
Unfortunately, you're developing an iPhone app with displays for
Good point.
That's right.
for a watch.
So we're constantly, we have to prepare, so we have to get used to this stuff and dive into this stuff now so we can be prepared for the demand later if students are really asking for these types of things. Anything else?
So the application works both. It can work on the iPhone and the watch. It's developing for both platforms. It's just the additional if there's the watch.
Right, right. Yeah, the code, at least right now, you would need your iPhone app to install the watch content, the component on the watch. But as Apple announced, we will be able to make native Apple Watch apps alone. So I'm not sure what that might look like, but does have potential. Yeah.
At this point, can you cache any information locally on the watch so that it would work even if it was away from?
You mean even away from the phone? Well, all of this content is in the app itself, like all of these these images and everything like that. But for the speech to text to work, it's just like Siri. It needs an internet connection to do that, to perform that logic. So this wouldn't work. This particular app wouldn't work without an internet connection. But you can cache content, yes, up to a certain size.
What's the size limit?
On the watch?
Yeah.
You know what? I don't know that off the top of my head.
That's a good question.
Yeah. All right, Justin, do you want to jump in and? Oh, sorry.
Just one question. What's your opinion on Swift compared to Xcode?
Well, Swift is a language. Yeah, what's the opinion of Swift versus Xcode? Swift is just a programming language that you can still use in Xcode, but you can still use Objective-C as well. So when you start a new project, you can choose which one you want to use. I'm finding Swift much more, I'm not going to say easier, but it makes more sense to me, just personally. I'm able to write quicker, and it's much more logical. But Justin will talk about that too on his.
Well, I can talk about some of that now. So I'm a big fan of Swift, simply because I'm not a developer. I started relearning. I took some basic classes in high school. I don't think that really counts. So I started learning Swift as basically my first development language and IDE. The learning curve. Now, if you already know Objective-C, you might not care for the transition to Swift. But if you know Python, or you know something, or you don't know any programming at all, Swift is great because of the learning curve. And obviously the frameworks that Apple provides are fantastic, and you can utilize all those frameworks. Swift works great with C code and objects and frameworks. It works great with Objective-C. It's terrible with C++, so if you have a lot of C++ code, it doesn't integrate well. You need Objective-C wrappers around any class or object to use it in Swift, at least currently. I'm not sure what Swift 2.0 will bring, but I haven't gotten into that. I am excited to be able to use Swift outside of kind of the Mac development environment with it going open source, so I'm looking forward to that as well.
And at WWDC, Apple announced that Swift is going open source, so it might be beneficial to learn it now, and who knows what ramifications that can have.
Debuggers?
Debuggers.
LLDB. So right now it's pretty tied heavily to the Mac ecosystem and Xcode. There is Fire is the name of the IDE that will actually allow you to program in Swift for Android, and it will compile to .NET and Java. And I would say you typically stays a version behind what Apple's releasing for updates to Swift. So I don't want to use it right now because I don't think it's quite there. But I think with Swift going open source, I think those tools will continue to grow. And I think if you're administering Macs, there's some great things that you can do with Swift. And if you're working in a Mac ecosystem, there's some great things that you can do with the Swift. And I don't think it would be an unwise investment. So typically a wise investment for a sysadmin might be Python or Perl or one of those, kind of cross command line development environments. But I think Swift is going to get there as well. And depending on the developer you're talking to, you can probably argue for weeks on end over what is better than the other.
I am like you, only much older, so it's been a while since I did my basic and Fortran stuff. What did you use to ramp up on Swift learning?
A project. So, trial by fire. Fortunately, I share an office with a a very well experienced web developer. So I can go, hey, explain to me what an object is. Explain to me how classes work. And that's great for me. But you know, I was able to learn from him. And then fortunately also the community around Swift right now is exploding. So Stack Overflow is just an amazing resource where you can get all kinds of answers for Swift. So I just moved forward and broke it and fixed it and broke it and fixed it.
Also, to add to that, the Apple documentation for Swift is quite good. It allows you just from the fact that it allows you to switch between, like, it might have a code snippet, and you can switch between Objective-C and Swift to see how the two correlate or the differences between them. So that's a nice feature.
I did not like the Apple documentation.
Brett's in the room, so I had to do that.
I learn better from looking at code and actually, if there's something I'm stuck on, I'll look it up. The documentation was not helpful for me, given my lack of experience.
See how it's heavily based off of the iPhone mentality? If you already have an app built in an iPhone, for an iPhone, is it easy to transition to this or get to build everything again?
So
The question was it easy to transition from an iPhone to the watch?
If you built a class, I'm sorry. The question was, how difficult would it be? Do you have to rebuild an app if you've already written in Objective-C, if you want to transition to Swift? So if you've built a class that does a lot of amazing things, I wouldn't rebuild it. I would continue to use it for now. But you can integrate it with a Swift project. Now, if your view controllers and stuff are in Objective-C and you have logic in there, you might have to rebuild that if you're going to make it a Swift project. But anything you have classed out and built properly, you should be able to reuse a lot of that code. I use a lot of C code frameworks and classes and Objective-C stuff too.
But specific to the watch, as long as your iPhone app in Xcode is the iOS version that can support the Apple Watch, all you have to do is just add the additional target in Xcode. So a new target, a WatchKit app, it'll go down through that, and you name it, and it will literally drop it right here. So all of a sudden now you have a WatchKit extension on your iPhone app. That's quite nice. Yeah.
So with the background and stuff that you have set up here for like site response, MC response,
right?
When you make it for the phone itself, does it resize itself when you make the target for the WatchKit as well, or do you have to redesign those as well?
So the question was, do you have to redesign view controllers for the phone versus the Apple Watch? And you'd actually design two. So in your phone app, you have a storyboard for your phone, which you can kind of cater to using the canvas of the phone, but you can repurpose art assets and code here as well. And in the WatchKit extension, or the WatchKit app, you also have the interface.storyboard for the watch. So you have a separate storyboard with their own view controllers. Just because, for the watch has force touch, so there's a whole different kind of layer of interactivity you can build for, so it requires its own storyboard, among other things. All right, well, I'm going to hand it over to Justin to show a Mac side of Swift and more of a utility.
So this is a really simple tool, but I did provide it if anyone's interested. I'm going to use a native framework or a system framework for pulling logs off of a computer. So I built a command line tool. I figured we'd build something that was a little more relevant to the conference here. And of course we could shoot messages via notification center to the watch if we wanted to. But basically what this app does is it uses Apple system logs. So I'm sure you're all familiar with this tool. which is fantastic. But the problem is automating this, so you can only do so much with this. If you run a Mac lab, I'm sure there are tools out there, but I'm just going to show you a simple one that you could build to do very specific things. And what this uses is Apple System Log, which is ASL. And I found a piece of code, which I've also attributed, that will basically take, it's a C library, but it will take this C library and it will provide, let me get rid of that. Oops. It will kind of format it in a more Objective-C Swift native format. So it'll build an actual dictionary. And then from my code, we can just kind of go through it a little bit. What we do is, as soon as the app is run from the command line, it will get the current date. And then we do just some basic formatting of that date. And anytime we initiate either a variable or even an object, we use either var or let. Let is a constant, var is obviously a variable. So again, just data formatting. And this is the class that we're calling from that other piece of code that really is just creating a dictionary around every single log in the console, so every single system log in the console. So from here, I'm just checking, hey, if the entry is login window, login processing, or proceeding, basically the system, every time a user enters their username and password to log into a Mac computer, and they hit enter, the system will log this event with the date and that text. So I'm looking for this. And then I'm going to take the timestamp and I'm going to add it, I'm going to append that timestamp to an array. Very simple. And then what I'm going to do is after we get through every single log, I'm going to reduce that so I'm just basically grabbing the most recent timestamp. And then after that I'm going to compare I'm going to grab the current time and date again so that now I know what time it was when I ran this application. I know what time the user hit login, and I know what time it was after I parsed through all the logs. And so basically what I do is I take the most recent log, subtract, or I compare the two times from when we ran and from when they hit enter to log in, and I subtract the time it took to parse those logs. And then if I run it, now, because this is a personal computer, I have a lot of logs. On a lab machine, it usually runs a lot quicker. And since I logged in yesterday, since my last login is 88,943 seconds. However, if we run this application on boot up, so on startup or at the end of, if you have a log scripts or scripts, boot up scripts that you use, if you run it at the end of that, you can now calculate from the moment they hit enter to the time the machine becomes available for user input, so running applications. And this will just print it to the terminal. But we could add something to where it sends an email or where it sends or posts it via HTTP to some server. Again, it's very basic kind of proof of concept, but we can look for anything in here. Anything that gets logged to console, we can look for that stuff. And we can also use the same library to post things to console as well.
So are you actually searching through the entire system log for this particular message? If so,
yes.
Have you considered limiting your query to a specific sender? The ASLC API has a key, like ASL key sender. If you pass that, it will only return messages from. So like if it's like com.apple.login window, you can pass that, and then the query will be like 100 times faster.
Yeah, I'm sure. I spent like an hour on this. So, but if I was gonna move into a production environment, I would probably look to reduce. Although I think on the lab machines, Rusty in the back ran it. I think it was like a 2-second query, because the user gets the profile gets deleted every 3 days on our lab machines. So the log file doesn't get very big. So it would be a.
You're also asleep a lot, so there's not a lot of logging going on during the day, especially during the summer.
So the things you can do with Swift are just as powerful as Objective-C, with the exception of maybe using a lot of C++ code. If you're willing to wrap your C++ code, Swift is just as powerful. And I believe it will get more and more powerful. And I'm not sure what the long-term future of Objective-C will be with Apple. I'm sure that's up for debate, but it'll be interesting to see whether they continue to support it 10 years from now. Questions?
So regarding wearables, are there any use cases, are there any explorations that you folks have done regarding wearables in your company or your campus that Apple Watch or Swift may accommodate? Have you thought about that or played with that? Yeah.
So I'm not supposed to say where I'm from, but it's a big...
I'll just read your name tag afterwards.
In Bethesda, we have a massive clinical center there, and it would be kind of ideal if we could set up eye beacons to help patients figure out their way through that maze. Mm-hmm. And just use the watch and go, yeah, okay, left, go, okay, right. Because there are literally ways in which the only way we can get to certain floors is by going the floor above, down the corridor, and then down a set of stairs. It's
right.
Insane. So that's one use case that would be kind of cool.
Yeah, in the short time that I've had an Apple Watch, one of the most useful things that I've found is turn-by-turn navigation. So when I set up a route on my iPhone, it automatically shoots it to the Maps app on my watch, and I don't even have to look because a left is a different vibration on my wrist than a right is. So if I need to turn left, it tells me right before, and I just feel it. If I need to turn right, it sends a different vibration, and I turn right. It's really cool. So being able to do that for even things like campus tours or navigating buildings, indoor location, would be really neat. Yes.
I think I thought about iBeacons a lot too for like individuals with disabilities or people as they're getting elderly towards dementia and that kind of thing. But I think the limitation right now of having to be within a specific radius of the phone makes it really limiting
right.
that way. So like if you could cache the information locally, then I think that would be a huge improvement, or there's potential that it's going to have cellular or...
Right.
We actually have some experience working with iBeacons kind of indirectly. A colleague of ours and our assistant director wrote an app for museums that would basically provide on-demand additional content about a painting. And it works fairly well, but the way iBeacons, their RSS, their radio signal strength, it contracts and comes out. It's not reliable for fine-tuned navigation. Now, if you're going down a hallway, you can probably use it that way. But there are some limitations to the technology that you might want to test if you're going to explore using it.
We're also working on an Apple Watch app now with a faculty member who's an educational psychologist. And we may end up using ResearchKit or exploring ResearchKit for this specific project. But she's interested in prompting students throughout the day using their iPhone or their Apple Watch and getting feedback about their learning habits or their mood. And we can use location data too. So if they just got out of a classroom building, the watch can throw a prompt up and say, how did class go? Or, if it's tied to our LMS, we could say, make sure to study for this exam. It's next week. Just these really short kind of, her interest is in what is the shortest amount of feedback that can get the most value from a student. So we'll be kind of A/B testing this using an Apple Watch and then the same kind of prompting through an iPhone and even our LMS separately too, just to see what the feedback differences are and things like that. So we're pretty excited about that opportunity too. And we'll be giving students these watches to explore this a bit. So.
And that's what you're planning in the fall?
Yes. Yeah.
DARPA is doing research on vets trying to, with their iPhones anyway, regarding mobility, and they found that the less a person traveled out of the home, the likelier it was some sort of occurrence was happening.
Oh.
So when they saw that vets were wandering around, that was cool, but if they had spent days not out of their house, They were able to correlate that to certain mood sets, and the research kit's helping them explore that a bit further.
Right.
I was wondering, as she was mentioning dementia, whether the accelerometer on the watch couldn't help. Probably the false positives would be too great, but for falls, in the case of elderly,
right.
They're wearing a watch and they fall. And is that something that could then be true?
You could probably combine the two things. So even with the false positives, maybe kick off a listening and look for certain, crying or calling out for help, that sort of thing. So if you combine the two, you could get rid of a lot of the false positives and then only alert whenever somebody is hurting.
And obviously, the creep factor here is pretty high. but with HealthKit, I mean, you can monitor things like heart rate too. So again, combining these different tools and ResearchKit has anyone kind of participated in a ResearchKit app? One of the health apps that Apple put out? It's really interesting. So we're hopeful that we can kind of use that same technology, but in an education setting.
Can I recommend you guys do? The amount of research the information that could be brought,
right,
would be staggering.
Mm-hmm.
Very valuable to researchers. A lot of it could be corrupt. Some of it is like any survey kind of stuff. But the more you can isolate the variables, the volitional variables from human subject,
right,
the more information you can get back, and then people can start looking at things like dementia and Alzheimer's and these other things. And those are the kinds of things that go straight into the medical research community for absorption and response.
Great. Thank you. We will.
Yeah, I think as we build familiarity with the technology, now we can start to approach the faculty that are more prepared to actually do the hard research, the hard stuff, and we can just provide the tools to assist those faculty.
Any other questions or comments or
thoughts,
points of discussion? All right. Well, that's the agenda we had, but we're happy to go through. I'm happy to do any kind of storyboard work or show a user interface or constraints or anything that you guys would be interested in looking at. Otherwise, we can kind of just hang out and take a break.
As far as constraints go, do you mind? I noticed that, you pretty easily were able to center the objects, and I'm good enough to the point where I can do that pretty easily. But I find that when adding more than a few constraints, it just becomes really auto layout becomes really difficult to work with. Do you have that same problem, or does the mental model work for you?
Especially when you're working with an app, a universal app for iPhone and iPad, it can get rather confusing. Let me switch back here. Sorry. But in Xcode, you can isolate specific canvases. So let me go into the main storyboard. So right here, so this grid is really helpful. So you can isolate views. So this is any kind of device, but I can look at it as if it were, what's 5.5? That's right, for 5.5-inch iPhones in landscape. Or if I wanted to look at the same thing, and then I can, the adjustments I make here, constraint-wise, are only set to that canvas. So you can really kind of isolate things really well. Or if I want to do all iPads, and the constraints I build in this canvas are specific to that canvas, and they don't confuse things.
Yeah, they call it, what is it, size classes?
Yes. Yep. So.
Yeah. I think it's pretty powerful. It can be frustrating.
Right. So you can see here are the constraints I have for this specific button. I have, width equals a height equals. I have bottom space and top space. This button is dependent on this label, or at least the top space is. And then that's for this specific size class, and then you can look at it for all size classes. And if I wanted to look at, here are iPhone 5s through, or iPhone 4S through 6. I can adjust things for that layout. So it's nice that I can separate them and look at these individual canvases, but it took some convincing for me to move to one storyboard for everything. But once you learn these things and how to use auto layout to your advantage, it becomes the most logical approach. Anything else?
Will students, you covered the creepy factor, will they opt into this trial?
Yes, they are opting in because we're providing them Apple Watches for this specific purpose. Yeah, it's 8 to 10 right now. So it is an opt-in right now. It's one specific course we're looking at, a very isolated research project. And then the good news is we can write this app for that specific set, and then if we want to open it up to larger things, it's very easily done. Especially with ResearchKit, because the whole goal of ResearchKit is to scale very, very easily. So we're pretty confident about that. Yeah.
Were there any particular challenges for you guys, like kind of getting started with wearables or just kind of connecting the dots?
So we looked at Fitbits first. We looked at Jawbone ups. We looked at kind of the whole landscape, and the Apple Watch kind of lent itself better to us because we're primarily an iOS shop anyway, so it made sense for us to look at it. Also, the customization you can do, the features of the watch are really compelling. But we did look at the whole wearable landscape and see what we could do. I think with Fitbit and Jawbone, you can do things with like if this then that. You can link it up to that, and some really neat things coming up the pike. But
now, does your group also do Android, or is that a different team? Or is it also
so we do Android as well. Very little, but
a little bit of Android. We're a team of 3, so we are limited to what we can learn and do at a given time and actually be effective with it.
And that's why we're excited about Swift and Swift being open source, because we can write one core piece of code and then port it to all the different flavors just with some framework changes. And so we're looking forward to that. It speeds up development. Well, we'll be here, so I appreciate your time. Thank you very much.